Hello everybody, I'm Sebastian Palacios.
And I'm Annalise Fench.
And this is our presentation on honeybees and colony collapse disorder.
For our question, we asked, what will happen to the honeybee populations in 1 year if the rate at which the bees die due to mites is increased due to a warmer spring?
Colony collapse disorder is a problem that has occurred with bees since 2006. It happens when a queen bee is left behind with immature bees and few nurse bees, but no forager or hive bees. Without foragers or hive bees, the colony ceases to function properly. A study done in 2019 by Carissa Palmer shows equilibrium between honeybees and Varroa mites in a hive. Following up on this study, we will be looking into the effects of a higher rate of deaths of bees due to the mites or raising the RO value.
So why are bees so important? They're pollinators, which means that they make it so plants can grow. We need plants to live as they produce the oxygen that we breathe. If that's not enough to convince you, listen to this quote from Albert Einstein. If the bee disappeared off the surface of the globe, then man would only have 4 years of life left. No more bees, no more pollination, no more plants, no more animals, no more man.
Let's take a look at the stock and flow diagram. If you look at the hive bees, there's a stock flowing in which represents the egg-laying rate of the queen as well as brood mortality. The stock flowing out represents the hive bees becoming forager bees, social inhibition, and the death rate due to the mites. The hive bees share a stock coming into the forager bees as they will become forager bees. The forager bees have a stock flowing in, and that represents social inhibition. The stock flowing out represents the mites and the death rate due to the mites. If you look at the mites, they're at the bottom of the stock and flow diagram. They have their own stock flowing in, which represents the carrying capacity of the mites in the hive, and a stock flowing out, which represents the death rate of the mites. They too share a stock with the hive bees and the forager bees, as they affect their population numbers.
We ended up with 3 equations. dH/dt is for the hive bees, which shows hive bees being born, minus hive bees dying naturally and becoming forager bees, minus the hive bees dying due to mites. dF/dt shows forager bees being born, which happens from hive bees converting into forager bees, minus the rate at which forager bees die naturally, minus the rate at which they're dying due to mites. dm/dt is our equation for mites, which shows mites being born, that is affected by the carrying capacity, minus the mites dying. It's important to note the differential equations had to be used. Insect reproduction rates are so high that they need to be tracked at small steps of time. Ours is in days. This means that difference equations just would not have worked because they would not have been able to track the insect reproduction within the time step needed.
Here are the assumptions we had to make for our study. The only species within the hive are the forager bees, the hive bees, and the Varroa mites. Colony collapse disorder is not defined as a single cause. There can be multiple explanations or different causes for colony collapse disorder, but in this case we will focus on Varroa mites being the only cause. The only value that will change is the RO value, or the rate at which the bees die due to the Varroa mites. The mites affect the forager bees at the same rate as the hive bees. This was found to be a minimal difference in the study and was held as a constant. The bees will reproduce rapidly enough to which they must be used in a differential equation.
Our first step was to get our code up to working order to match the results of the study. This meant if we used the exact same values as the study, we should get the exact same graph. Once we figured that out, we began finding ways to tweak the rho value. We discovered that the rho value will increase naturally between winter and spring. This is due to the ability of mites to enter the hive easier in warmer temperatures. Because winter is approximately 90 days long, we implemented the change 90 days in. This means that the year for the hive starts on December 21st and ends at the end of fall the next year. We also implemented 2 changes in rho, one for this typical increase between winter and spring, and one for a more drastic rate of increase. Here you can see our table of parameters. we have two separate tables, one for the values that remain constant and one for our row values, which change throughout the study. A couple of the values we would like to point out are that our hive bee population started with 14,000, our forager bee population started with 7,000, and our mite population started with 100. These values were again pulled from the study that we were basing this off of. Our row values changed slightly at first and then had a more drastic spring increase as seen in the table. This is what our code looked like. This is actually in one file that had 3 functions put into it. To change the row values, we used an if-else end loop with the time span of 90 days for the first row value and then for the rest of the year for the second row value. If you follow the arrows, you can see the order that the code went in.
Let's take a look at the graphs as they give us a result of our study. Here we can see the natural change of RO between winter and spring months, as well as the change in RO due to spring being warmer quicker. The hive bees have diminished from 25,255 to 17,639. The forager bees have diminished from 7,130 to 4,928. And the mites have also diminished from 348 to 314. Now, we can see that mites actually decrease in population, but they leave a really devastating effect on the hive bees and forager bees. These are the results that you get when you double the RO value.
In conclusion, colony collapse disorder has already proven its deadliness to scientists since 2006. The bee populations of the world have been plummeting. With evidence that this disorder gains a stronger foothold in colonies in warmer spring months, and that spring months are getting warmer each year, it is clear that there will be a problem in the future if a cure is not found. Higher rates of death of bees due to mites, or the row value, have shown that the colony bee populations will trend to lower values. If measures are not taken to save bee populations from this disease, there may not be a future for bees on this planet. If there are no bees, it is likely that life on Earth as we know it will cease to exist.
Here's our final presentation poster. To the top left, you can see the background, which was a basis and inspiration for doing this study. Below that are equations and assumptions that led us to our results. In the middle, you see our table of parameters, as there were many, and right below that, you see our change in RO. To the right, you see our stock and flow diagram, as well as our approach. And to the far right, you see both our graphs, so you can analyze what the change in RO did to both populations. And our conclusion is that if measures are not taken to save bee populations from this disease, there may not be a future for bees on this planet. If there are no bees, it is likely that a lot of life as we know it will cease to exist. Here are our citations, and the most noteworthy to mention is Carissa Palmer yet again, because her study on honeybee and Varroa Destructor population dynamics in 2019 was the basis and our inspiration for delving into this issue.
Thank you for watching our presentation. Remember that bees are an important part of the environment, so do what you can to save the bees.